All right, in this video, we're going to do an exercise, and the expectation here is that we write down two trig expressions involving sine whose value is identical to the given one on the interval negative 360 to 360. So this is a simple exercise. It's good as a way of kind of like helping you strengthen your conceptual understanding of unit circle trigonometry. Okay, so let's just set up a unit circle here. Let's say we rotate 132 degrees. That's like there, we'll say. So that's 132 degrees. So the first thing I always like to do is just indicate that point right there. The coordinates of that point can be written as cosine of 132 degrees. And the y coordinate is the sine of 132 degrees. Okay, so that point has, right, so if I'm just going to highlight there, the y coordinate of this point is this length. It's just not letting me, it's not letting me highlight for some reason, but is right here. Okay, that length there is the sine of 132 degrees. So the first thing you can do is you could just rotate the negative, a negative angle and get to the same spot. So if you rotated that angle in standard position, you'd end up in the same spot, and the sine of that angle would be identical to the sine of 132 degrees. So you can, maybe we'll think of it this way. You rotate 180 and then an extra, whatever this acute angle is. Well, if 132 brings you here, that means you need to go an extra 8 and then 40 to get to 180. So this must be 48 degrees. So if this is 180 plus 48 degrees, that's the same as 228. So this is the same as the sine of negative 228 degrees. There's a little identity we can use here, which I expressed in a different video. This is the same as negative sine of 228 degrees. So already we've done what we needed, right? We've done 2 here, because the sine of negative 228 degrees is one trig expression, and negative sine of 228 degrees is the other one. But we could even go further. So like, let's note this reference angle here, this 48 degrees, right? Let's say we wanted to just rotate that amount and end up in quadrant 1. Oh, it always does that. Let's see. Let's clean that up a little bit. If you rotate 48 degrees, that brings you here. So that point right there, its name is cosine of 48 degrees, sine of 48 degrees. But the key insight is, even though I didn't really do a good job drawing them to scale, this must be the same length as this. So you could even say that sine of 132 is equivalent to the sine of 48 degrees. And we can get one more if we use our identity above here. The identity I'm referring to is that the sine of negative theta is negative sine of theta. We can think of this as sine of negative 48 degrees. And according to that, it's negative sine of negative 48 degrees. So in all, we've done way more than what was asked, but I can say that the sine of 132 degrees is equal to the same as the sine of negative 228 degrees, which equals the negative sine of 228 degrees, which equals the sine of 48 degrees, which equals the same as the negative the sine of negative 48 degrees. So those are all expressions involving sine. The angles are all in between negative 360 and 360. It's not all of them, but let me just kind of show you or convince you that these are all the same. If I haven't already with this video, you might just go check for yourself on Desmos. Just plug all these in and see if you get what you think you should get. So this is sine of 132. Let's punch in the sine of negative 228. Let's do negative sine of 228. And the sine of 48. And you can see so far so good. And how about the negative sine of negative 48? And there we are. So essentially, what we're saying is that the y coordinates of, or the y coordinates in absolute value for all these locations on the unit circle, they're going to all have the same length if you rotate all these amounts and fix with negation if you have to. But in any case, we did what was asked. Simple exercise, but there's a lot to be gained from just exploring that one question as best you can.